These two videos came from the same workplace training prompt. The one on the left is 10 seconds long. The one on the right is 15. I asked for a visitor to present photo ID at reception, receive an orange visitor badge, and then be escorted beyond reception. The 10-second version shows that sequence more clearly. In the 15-second version, orange badges appear on the counter, but the visitor is later holding a white card. The handoff I asked for is never clearly established. The photo on the ID also appears inconsistent with the visitor on screen. So the longer clip was not the cleanest result in this sample. I generated 4 videos from the same prompt inside TalentLMS. Before deciding whether any of them could be used for employee training, I reviewed the procedure, the visual continuity, the generated text, and the credits deducted from the account. The question is whether one of these clips is accurate enough to publish. TalentLMS provided the premium trial access and AI credits used for this test. GrowthStack is also a TalentLMS affiliate, so I may earn a recurring commission if you become a paying customer through the link below. I set the review criteria before judging the outputs. AI video is a broad label for software that creates video from a script, text prompt, or source image. The tools do different jobs. Some turn a finished script into a presenter-led video. Others generate a short visual scene from text or an image. This test covers a generated scene created inside TalentCraft, the course authoring area of TalentLMS. For a training team, the appeal is practical. A short scene could illustrate a workplace procedure without arranging a small shoot. It could also work as a visual example inside a larger lesson. I did not test this feature as a complete video production system. The shortcut is useful only if it preserves the instruction. By the end, you will have a review method you can adapt to other generated procedural scenes. I will also show what the 4 runs produced and how the account balance changed during the test. For this test, the review standard came directly from the instruction I gave the generator. First, the visitor has to present photo ID at reception. The image needs to establish that action clearly enough for a learner to recognize it. Next, the visitor has to receive an orange visitor badge. Showing an orange object somewhere in the scene is not enough. The sequence needs to connect the badge to the visitor. The host then escorts the visitor beyond reception. A host appearing for a moment does not complete that step. The movement beyond the reception area has to be visible. Those requirements also have to stay coherent from one shot to the next. If the visitor changes, the ID belongs to somebody else, or the badge changes color, the learner has to interpret a contradiction that was never part of the procedure. Generated words need their own check. A badge or wall sign can appear plausible at normal playback speed while containing malformed text when viewed properly. In operational training, small details can carry policy, identity, or safety information. A reviewer cannot assume they are harmless decoration. This gave me a simple publication standard. Does the video show the requested procedure? Do the people and props remain coherent? Does any generated text introduce a problem? I used that same standard for every output. Inside a TalentCraft unit in my premium trial portal, I opened the AI menu and selected the option to create a video. The composer gave me a prompt field, a duration control, and a button labeled Start Creating. The captured control offered lengths from 6 to 15 seconds. I am keeping that statement tied to the interface I observed in this account. I did not test what other plans receive, and I am not using this screen to infer anything about licensing, export, or editing. I entered one fixed prompt. It asked for the exact visitor check-in process we have just defined, requested an English voiceover, and told the generator not to add other rules. For each run, I selected a duration and started the generation. The interface moved into a waiting state and then returned a video player inside the unit. The captures proved the 6-second and 15-second selector states. The 10-second run is confirmed by the generated player's recorded endpoint. Once the outputs existed, I stopped treating the interface as the main subject. The 4 generated clips became the evidence. I made 4 generations. The selected lengths were 6 seconds, another 6 seconds, 10 seconds, and 15 seconds. I kept the written prompt fixed. I did not hide an unsuccessful result or generate replacements until I found a cleaner set. These are the 4 confirmed generations from the test. All 4 included English narration and reached the selected playback length. That establishes that each generated video reached its selected playback endpoint. It says nothing yet about whether the result teaches the procedure correctly. There is also an important limit to the comparison. A generative system can produce different people, props, wording, and scenes from the same input. With 4 outputs, I cannot separate the effective duration from ordinary generative variation. If the 15-second clip has a different defect from the 10-second clip, I can show the difference. I cannot claim the extra 5 seconds caused it. The 2 6-second runs make that limitation visible. Their prompt and selected length were the same, but they did not fail in the same way. I will let the first 6-second video play once before taking it apart.
Presents their photo ID at reception.
Here's my ID.
I'll escort you in.
The opening action is clear. The visitor presents an ID at reception. An orange badge is also handed over and shown. The problem arrives at the final step. A host appears, but the video does not clearly complete the movement beyond reception. If the clip is meant to teach the whole check-in procedure, the visual sequence stops short of the requested outcome. The badge also contains malformed generated text. That issue is secondary to the missing action, but it still prevents the frame from passing without review. Now compare that with the second 6-second generation.
The visitor presents a photo ID at reception.
Here's my ID. Here's your badge.
The host then escorts the visitor inside.
This version shows the ID, the orange badge handoff, and the escort beyond reception. Against the basic procedure checklist, it covers more than the first run. The ID creates a continuity problem. The photo on the card appears to show a different person from the visitor presenting it. The same visitor then remains on screen through the badge handoff and escort. A matched view of the ID photo and the visitor makes that mismatch easier to inspect. The break is between the credential and the person, not between the later shots. The same prompt and the same 6-second setting produced 2 different review outcomes. One did not clearly finish the procedure. The other completed the requested actions but paired the visitor with an inconsistent ID photo. This is why a checklist of events is useful but incomplete. A generated clip can include every requested action and still fail as one continuous piece of training. The 10-second output was the strongest of these 4. Watch the complete clip first.
The visitor presents a photo ID to the receptionist.
Good morning.
I have an appointment.
Here's your visitor badge.
The visitor receives the orange badge and clips it on. Hello, I'll escort you in. Thank you.
This version gives each required action enough visual space to read. The visitor presents the ID. The orange badge is received and then worn. A separate host arrives and escorts the visitor away from reception. Character continuity is also stronger here. The visitor is more coherent across this sequence than in the other reviewed outputs, and the host enters as another role instead of replacing the person who was being checked in. That is the basis for calling it the strongest result in this sample. It is an editorial comparison of the 4 videos on the procedure we set. It does not establish 10 seconds as the best setting for another prompt or another generation. The stronger sequence still contains material that I would not publish unchecked. The video invents TechCorp Solutions branding even though the prompt did not provide a company name. Generated lettering on the sign and badge is also distorted or inconsistent. Invented branding can be more than a cosmetic annoyance. A training team may need the asset to match a real organization, a client, or an approved internal awareness. A plausible fictional name can make the result look specific while being wrong for the place where the training will be used. Distorted text carries a simpler problem. The model has created a visual object that resembles written information without producing reliable written information. If that object stays in the frame, a human has to decide whether it can be cropped, replaced, or rejected. I did not test editing controls here, so I am not claiming that correction can happen inside TalentLMS. The 10-second clip therefore travels furthest through the review. It covers the required procedure with the best continuity of this set. It still stops at generated text and invented detail. The 15-second output contains more narration and a clear escort action. It still does not produce the cleanest visual result in this sample.
Presents a photo ID at reception. Good morning, I'm here for a meeting.
Welcome. May I see your ID, please?
The receptionist issues an orange visitor badge.
Thank you.
Please wear. The host then escorts the visitor beyond reception.
Hi, I'll take you to the conference room.
The clip does show the visitor presenting an ID. It shows orange visitor badges on the reception counter. A host arrives, greets the visitor, and escorts her beyond reception. The uncertain part is the badge handoff. We see the receptionist produce orange badges, but the footage does not clearly establish one being handed to or worn by the visitor. Later, the visitor is holding or wearing a white photo ID-like card. I cannot rename that object to make the sequence pass. The prompt asked for an orange visitor badge. The later object is white, and the available frames do not establish that it is the requested badge. There is a separate continuity issue in the ID shot. The photograph on the presented card appears to show a different woman from the visitor holding it. The ID image and the visible character do not remain coherent. The badge close-up adds another generated text problem. The large word visitor is recognizable, while smaller lettering is malformed. The video also adds meeting context that was not needed to show the requested procedure. The escort is clear, and the narration describes the sequence in more detail. The visual contradictions remain. A learner receives information from the pictures and the voice at the same time. If the voice says a badge is issued while the pictures fail to connect that badge to the visitor, the training asset asks the learner to repair the sequence mentally. In this test, the 15-second output still needed review and did not beat the 10-second result on the standard we set. Putting all 4 outputs on the same board makes the result easier to judge. The first row is step coverage. Run 6A clearly shows the ID and badge, but the escort beyond reception is not completed visually. Run 6B shows all of the requested actions. The 10-second output also shows the full sequence. The 15-second output shows the ID and escort, while the orange badge handoff remains partial. The next row covers character and prop continuity. Run 6B pairs the visitor with an inconsistent ID photo. The 10-second output holds together better across the required sequence. The 15-second output contains the ID photo inconsistency and the unresolved change from orange badges on the counter to a white card with the visitor. Generated text creates problems in more than one output. The first run contains malformed badge text. The 10-second result invents a company identity and includes distorted lettering. The 15-second badge also contains malformed smaller text. These findings do not support a product-wide success rate. 4 generations from one prompt are too small and too narrow for that. They do support a decision about the clips in front of us. Every column ends at human review, but the reason is different. Run 6A needs the procedure completed. Run 6B needs its ID continuity repaired or the clip rejected. The 10-second result needs its invented branding and text checked. The 15-second result needs the badge sequence and ID continuity resolved. The 10-second column remains the strongest in this sample because it shows the requested steps with the most coherent sequence. It receives the same review requirement as the others. The account started with 15,000 AI credits. After the first 6-second generation, the captured balance was 14,880. That is a deduction of 120 credits. After the second 6-second run and the 10-second run, I checked the balance at 14,440. That intermediate figure was confirmed during the test, but I did not preserve it in a balance screenshot. It needs to stay labeled as a user-confirmed checkpoint rather than captured product UI. After the 15-second generation, the captured balance was 14,140. Across the 4 confirmed generations, the observed deduction was 860 credits. The first 6-second deduction and the final 15-second deduction are consistent with a simple calculation of 20 credits for each selected second. Applying that calculation to all 4 clips would predict a total of 740 credits, leaving an expected balance of 14,260. The observed balance is 120 credits lower than that calculation predicts. The captured interface says creating a video with AI costs up to 300 credits. Its tooltip also says a 15-second video costs up to 300. Those statements give us a ceiling. They do not provide a transaction history for the 4 actions. The unexplained amount sits inside a combined checkpoint covering 2 generations. The available evidence cannot assign it to either one. I cannot call it an overcharge, a hidden fee, or a bug. The accurate conclusion is narrower. The captured total deducted was 860 credits, while the simple duration-based calculation predicted 740. A difference of 120 credits remains unexplained by the evidence available in this account. For this kind of training asset, generation belongs before the publishing decision. Start with the procedure that has to be taught. Turn its essential actions into a review standard before generating anything. In this example, that standard came from the photo ID, the orange visitor badge, and the escort beyond reception. Then, inspect the complete output once at normal speed. A first viewing tells you whether the sequence makes basic sense. A second pass can check the points that learners may copy. Who performs each action, which object changes hands, what appears in written text, and whether the ending completes the instruction. The review should compare the final pictures with the source procedure, not with the smoothness of the voiceover. A fluent narration can make a missing visual connection easier to overlook. I would use these outputs as first drafts, then verify the procedure before a learner sees them. The person responsible for the training still decides whether to correct, replace, or reject each scene. I did not test the correction workflow inside the product, so the review gate on screen is a growth stack framework rather than a TalentLMS control. The 10-second output was the strongest of these four. None of the four was ready for me to publish without human review.